In this next example, we have 36 cars. That were sold at a dealership. To determine the number of days each car sat on the dealership's lot before it was sold. The sample mean was 9.75 days, with the sample standard deviation of 2.39 days. We need a C level of 99%, and we're supposed to create a confidence interval. Okay, so let's check our conditions. First of all, it is random. We do not know the population standard deviation. And they tell us that n is 36, which means n is greater than or equal to 30, so we can proceed. Next, let's find our t-distribution critical number, critical value. We need our degrees of freedom in order to do that, which is 36 minus 1, or 35, is our degrees of freedom. Our confidence level is 0.99, so using our confidence level of 0.99 and our degrees of freedom of 35, using the table in the back of the book, we get 2.724 is our critical value. From there, we find our margin of error, which is plus or minus 2.724 times the standard deviation, 2.39, divided by the square root of n, which is the square root of 36. Plugging that in to our calculator, we get plus or minus 1.08506. From there, we want to find our interval. For our interval, we want to take our sample mean, which is 9.75 days, subtract our margin of error, 1.08506, and that has to be less than our actual population mean, which is less than our 9.75 plus our margin of error, 1.08506. Oops, I wrote that wrong. There's an extra zero in there. 1.08506. And that comes out to be, having our interval, 8.665 to 10.835. Remember, using technology, you would go to stat, then you would move over to tests, you would go to t interval, and we want to use stats to calculate it, and use all those stats that you had up there. Our x bar is 2.3, excuse me, x bar is not 2.39, x bar is 9.75, s sub x is 2.39, n is 36, and our C level was 99 for this one, which leads us to our conclusion, which says we are 99% confident. That's pretty confident that the population mean number of days that a car sits on the lot is between 8.7 and 10.8 days. So as you're doing these confidence intervals, you always have to ask yourself, should I be using a normal distribution or a t-distribution? And follow this flowchart and you'll know what to do. In fact, put this flowchart out when you're taking the test so that you can decide what to do. First of all, is the population normally distributed, or is n greater than or equal to 30? If that is not true, then you cannot use either of them. Then you have to stop, and you cannot perform these tests. If it meets those conditions, then you ask yourself, do we know the population standard deviation? If you do know it, you use the normal distribution. If you do not know it, that's when you use the t-distribution. Okay, so here we have an example. You randomly select 25 newly constructed houses. The sample mean construction cost is $181,000, and the population standard deviation is $28,000. Assuming the construction costs are normally distributed, they told us they met that condition. Should you use the normal distribution, the t-distribution, or neither to construct a 95% confidence level? So first of all, your first thing on your flowchart says, is it normally distributed or is n large enough? Well, n is not large enough, but they told us that it was normally distributed. So that means we go on to decide, is the population standard deviation known? And in this case, yes, it is. That means you proceed with a normal distribution. Okay, on this assignment, you're going to be working on page 330. You're going to be doing the odds from 1 through 27.